You're standing on an escalator right now, but do you know what's actually moving underneath your feet? Hundreds of individual steps are connected together in one continuous loop. And somehow, a motor, chains, gears, and wheels make all of them move together perfectly. But how does this complicated machine actually work? To understand it, let's start with something we've probably all seen before. Escalators are everywhere, in shopping malls, airports, subway stations, and huge public buildings. They're designed for one simple purpose: moving large numbers of people between different levels. And unlike an elevator, an escalator doesn't have to stop and wait for another trip. It can keep moving continuously, carrying one group of people after another. But the machine underneath those steps is far more interesting than it looks.
But the idea of moving stairs is actually much older than you might think. The earliest concept of an escalator can be traced back to the 1800s. Early designs were sometimes described as revolving stairs. But it took several decades of engineering before a practical working escalator became a reality. So why use an escalator instead of an elevator? The answer is simple: capacity. An elevator can only carry a limited number of people during each trip, but an escalator can continuously move people between floors without stopping. That's why they're especially useful in places where thousands of people need to move through the same area. You'll often see two escalators working together, one carrying people up and the other bringing them down.
Now let's take a closer look at the escalator itself. An escalator isn't one giant moving staircase. It's made from hundreds of individual steps connected together into one continuous loop. Each step has a special ridged surface that gives passengers better grip. You'll also notice the yellow markings around the edges. These help passengers see where they should avoid standing. But the really interesting parts are underneath. Every step has wheels attached to it. These wheels don't simply spin freely. They travel along carefully shaped tracks. And that's what keeps the steps level while the entire staircase moves. There's also something called a step chain. Think of it as the backbone of the escalator. The steps are connected to this chain, and when the chain moves, all of the steps move with it. The step chain is basically the backbone of the entire escalator. But the chain alone isn't enough. The wheels need a track system that tells them exactly where to go. There are carefully positioned tracks running through the entire machine. Their shape is extremely important because it controls the position of every step. While you're riding the escalator, the steps need to stay almost perfectly horizontal. But when they reach the top or bottom, something very different happens. Let's follow just one step. As it approaches the end, the tracks begin to change position. The step slowly tilts, then rotates around the end of the escalator. It eventually flips underneath and starts traveling back in the opposite direction. Once it reaches the other end, the same process happens again. The step rotates back into its normal position and becomes ready to carry another passenger. So every step is actually traveling around a giant loop.
So now we know how the steps stay connected and how they travel around the loop. But something still needs to pull that entire system. That's where the motor comes in. The main electric motor is usually located near the top of the escalator. When electricity reaches the motor, it begins rotating. That rotation is transferred to a large drive shaft. The shaft is connected to large gears that pull the step chain. As the chain moves, every connected step moves with it. But the motor isn't directly doing all of the work alone. A series of gears and chains transfer the motor's rotation to different parts of the escalator. This allows one motor to coordinate the movement of the entire machine. And there's another part that needs to stay perfectly synchronized with the steps: the handrail.
The handrail might look like a completely separate system, but it's actually connected to the same mechanical system. The motor's rotation is transferred through additional gears and a smaller roller chain. This mechanism drives the handrail along its path. And there's a very important reason for this connection. The handrail needs to move at almost exactly the same speed as the steps. Imagine stepping onto an escalator while the handrail was moving much faster than your feet. You'd constantly feel yourself being pulled forward. If it moved slower, you'd feel the opposite effect. So the gears are carefully designed to keep these two movements synchronized. All of these components have to fit inside one enormous supporting structure. This structure is called the truss. The truss supports the tracks, chains, gears, and other mechanical components while keeping everything aligned. Without that rigid frame, the entire system couldn't maintain the precision it needs to operate safely.
Now, there's one final part we need to look at: the ends of the escalator. At the top and bottom, you'll find something called the comb plate. It sits where the moving steps meet the stationary floor. As the steps approach the end, they pass underneath the comb plate. The small teeth on the plate fit into the grooves on the steps. This creates a smooth transition between the moving staircase and the floor. Those grooves also help reduce the chance of objects becoming trapped between the steps and the landing. And remember, an escalator is a powerful machine with many moving parts. That's why you should never play around the edges or try to interfere with the moving mechanism. So let's put everything together. The motor provides the power. Gears and chains transfer that power. The step chain pulls the steps around their continuous loop. Wheels follow carefully designed tracks to keep every step level. And another set of gears keeps the handrail synchronized with the steps. All of it is held together inside the truss. What looks like a simple staircase is actually a carefully coordinated machine working continuously beneath your feet. And that's how an escalator actually works.